Hello everyone. So chapter 7 and then again in chapter 8 as well talks about calculations that basically are used to alter medication recipes, for lack of a better word. So if you work in a compounding pharmacy or even a retail pharmacy or hospital pharmacy, sometimes you have to make medications in a different amount or a different strength than is originally prepared. So just right about now, we should have gotten to this point in PHA 110 where we're starting to do some compounding. And when we start talking about compounding, we will be talking about weight, volume, and volume weight preparations. And so what that means is we have the solute that goes into the solvent. So let's think about the easiest way to think about this. It would be with amoxicillin powder. We've already worked with that at this point. So the solute is the actual pink powder. That's the actual drug, that's the active ingredient, that's the important part. But it goes into water. I know actually the water goes into it, but you get the point. The solvent is always more than the solute, and water is the most common solvent, although there are plenty of other things. So in each of these, we're talking about a solute and a solvent. So weight means something that has weight. Like our first problem here, zinc oxide is a powder, so it has weight, and it's going into an ointment base, which also has weight. We have weight volume. That's the amoxicillin. You've got a weight, the powder that goes into the water. We've got volume. That's like bleach water. So you can have a little bit of bleach that goes into some water. And then volume weight, which is really strange. You don't see that often. We will do one compound in class that's a volume weight, and you'll know it when you see it because it looks completely different from everybody else. But this is the concept. This is what we're talking about. One thing is going into another thing to make a drug. So if you recall back with percentages, we said early on that a percentage is something out of 100. So let's look at this first problem. You are to prepare 120 grams of a 2% zinc oxide ointment. So anytime you see 2%, whatever percent, 2 out of 100. That's what that means. 2 grams in 100 grams, in this case, because it's weight, of product. So if we wanted 100 grams of zinc oxide powder or zinc oxide ointment, all we'd have to do is add 2 grams of the zinc oxide to 100 grams, or 98 grams actually, of Vaseline or some other ointment or cream base, and we'd have our product. Well, but the doctor orders 120 grams. So how much zinc oxide do we need to make that 120 grams? Well, so, I've been encouraging you to think about this kind of holistically and pull back a little bit. So if there's 2 grams of drug in 100 grams of base, this is 120 grams of base. So how much do you think this is going to be? 120 is a little more than 100. So odds are this is going to be a little more than 2. So let's take a minute and do the math. 2 times 120 divided by 100, 2.4. Which makes sense, right? Because 2.4 is a little bit bigger than 2, and 120 is a little bit bigger than 100. Okay, so let's take a look at the next one. Patient is to be given 1 gram of magnesium sulfate. The label on the vial reads 50% solution of mag sulfate. How many mils will you need? Okay, so 50% mag sulfate. 50 over 100. Okay, and we need to give 1 gram not 50, but 1. So how many milliliters will we need to fill this order? Okay, so 1 times 100 divided by 50 is 2. Now, again, with these kind of problems, if you want to know if you're right, put the 2 in the x place, your answer wherever the x is, and take out one of the other numbers that you know is true. You know 50 is true because it tells you, and see if you're right. So the next one, you have 20 milliliters of 2% lidocaine on the shelf. The order calls for 100 milligrams. How many mils do you need to use? Okay, so 2 out of 100. The problem is this is grams. It's always grams out of 100, okay? The order calls for 100 milligrams. So we have to do this one way or the other. We either have to change 2 grams to 2,000 milligrams to match milligrams over here, or change this to match that. So let's think about this for a second. I would go ahead and do 2,000, because 2 grams, 2,000 milligrams. And order calls for 100 milligrams. So how much do you need? So 100 times 100 divided by 2,000 equals 5. Okay? So if you want to try to do it the other way, let's try it and see what happens. So 2 grams over 100. Now we got to make this side match this. So instead of 100 milligrams, we're going to need to make that grams. So let's do this. 100, and remember our decimal, and we go back 1, 2, 3. So 0.01 over x. So let's see if this works. 0.01 times 100 divided by 2. And that gives us 0.5. And why is that not matching? I'm going to pause a minute, guys, figure this one out, and then I'll come right back. Okay, guys, sorry about that. I figured out what I did wrong, and hopefully by now you probably did too. So when I was taking my milligrams to grams, I added an extra space. Let's come up here, and I'll show you what I did wrong so you can kind of learn from it. So I was doing 100 milligrams, right? And I put my decimal here, and I did 1, 2, 3, and then I went an extra one. So I ended up with 0.01, and it should have been 0.1. So I'm going to flip this over. Actually, I want you to still be able to see it. So I'm going to start this one over again. So that we can see it from start to finish. Okay, hopefully everybody can see that. So again, if we've got grams over here, we have to have grams over there, or milligrams to milligrams. They have to equal. So let's start this again. You have a 2% solution. 2 means 2 grams out of 100. And the order calls for 100 milligrams. Okay, so this is grams. This is milliliters, because this is a weight volume problem. 100 milligrams in how many milliliters? Okay, so something has to change. We either have to change these grams to milligrams or the milligrams to grams. So we're going to do it both ways. 2 grams is 2,000 milligrams. Okay, If you do the math, you're going to end up with 5 milliliters, because that's what we want. Down here is milliliters. So on this side, same problem. We've got 2 grams over 100 milliliters. Now, in this case, we're going to change our milligrams to grams, and that is going to be 0.1 grams over X milliliters. And if you do the math again, you're going to still end up with 5 milliliters. So it doesn't really matter whether you change your grams to milligrams or milligrams to grams. It makes no difference as long as you are consistent with it and you've got it all in the right place. And again, you know, if you make a mistake, if something doesn't seem right, if you decide to do it both ways and get 2 different answers, take a deep breath. All that means is you just need to do a little more investigating as to what you did wrong. Everybody makes mistakes, so let's just make our mistakes and move right along. The next problem, 10% solution, calcium gluconate, 10 over 100. And you receive an order for 1.2 grams of calcium gluconate. So how many milliliters of solution should we use? So let's think about this. There's 10 in 100, 10 grams in 100 milliliters, and we only need 1.25 grams. So you can already tell which direction the number is going to go. It's going to be smaller than 10. So let's do 100 times 1.25 divided by 10, 12.5. And that's 12.5 milliliters. So 10 grams of drug goes into 100 milliliters of liquid. 1.25 grams of drug would go into 12.5 milliliters, so much smaller. Okay. We got a 1% solution. So 1 gram out of 100. And here's another one with milligrams. 50 milligrams. So how much can you prepare? Obviously, I do better with making my grams to milligrams, so I'm just going to change it over here. 1,000 milligrams. So 50 times 100 divided by 1,000 is 5. So 5 milliliters. Okay, we'll do a few more. Hydrocortisone topical cream is available 0.2%. 0.2 out of 100. Sorry, you can't see that. How many milligrams of hydrocortisone are in a 1 pound jar? Well, remember, we don't like anything to be in household measures. We want to switch it to grams. So this is a weight problem. So a powder is going into a ointment or a cream. So X over 454. Now, where did I get 454? 454 grams in 1 pound. So let's do our math. Okay. 454 times 0.2 divided by 100. 0.908, so I would just say 0.9. Okay, and if you think about it, if there's 0.2 grams in 100 and this is 454, well, it's going to be about 4.5 times this, because this is about 4.5 times that. So think about it equally and how holistically. Okay, let's try this one. We have a 50% solution, and this is a volume solution because how many milliliters are in? That's a solvent going into a solute. 50 X over 35. So if there's 50 milliliters in 100, there's going to be far less in 35. Let's do the math. 35 times 50 divided by 100, 17.5, which is much less than 50. Okay? And the last one of this type of problem, how many grams of amino acid are in a 500 milliliter bottle of 5.2%? So 5.2 over 100, how many is in 500? And think about this one again. 500 is 5 times 100. So technically, you could multiply this by 5 and get the same answer. But let's do it the way we've been doing it, just for consistency. 500 times 5.2 divided by 100. 26. And just for argument, let's do 5.2 times 5, and you also get 26. So, okay, the next type of problem is a dilution, and at some point you're going to ask yourself, with these two types of problems and then the one in the next chapter, how do I know which one to use? Sometimes that can be difficult, but if you start trying to set up the problem one way and you realize, wait a minute, I don't have enough information to do that, that's when you know you can kind of switch gears to the next way. And the best way to work with these problems is to just do a bunch of them. And I know that's not what you want to hear, but that's the truth. So next semester we will do some review of this, and to make sure that you've got 100% faith in yourself when you go take this test, the certification test, that you can do this. So dilutions, if you just follow this format, this should work out for you. So initial volume times initial percent equals final volume times final percent. Okay? So we're going to plug in everything where it needs to be. So how many milliliters of a 25% solution can be prepared from 750 milliliters of a 65% solution? So this is actually what we started with. Our initial volume is 750. The initial percent strength is 65. And that equals, well, how many milliliters? We don't know. So that becomes X multiplied by 25. Okay? Now this one is not a ratio proportion. This is more of a straight algebra problem. You have to do one side and then the other side. So 750 divided by 65. I'm sorry, times 65 is 4,875, 750, okay? Now, and then 25x. X likes to be by himself, so we're going to divide this number by 25. X equals 1950. So what we're saying is, if we diluted, if we added water to the original solution, how much could we make if we wanted to dilute this down to make it 25%? Okay, let's try another one. If 30 grams of a 45% powder was diluted to 30%, how many grams will the new preparation weigh? So initial volume is 30 times 45% equals X. We don't know the final amount, times 30%. I'll put the percent signs here to make it easier. So 30 times 45. 1350 equals 30x. X equals 45. Okay, let's do another one. If you dilute 2 liters of a 65% solution to 30%, how many fluid ounces, beware of that, Well, the new preparation measure. So you had 2 liters. Let's make it 2,000 milliliters because we're going to have to go to ounces eventually, and it's easier to do that when you've got milliliters. So 2,000 milliliters times 65 equals X milliliters times 30. So let's do that together. 2,000 times 65. Okay. 1, 3, 0, 0. Lots of zeros. 1, 2, 3, 4 zeros. It's 30x. Divide that by 30. And you end up with 4,333 milliliters. Well, that's not what it asks for, so be careful. It's asking for fluid ounces. So 4,333 milliliters divided by 30, because remember, there's 30 milliliters in an ounce. That leaves about 144 ounces. Okay? Okay, let's take a look at this one. How many grams of a 10% phosphoric acid can be made from 1 kilogram of 85% phosphoric acid? So we've got an issue here too. We've got grams and kilograms. So the initial volume is 1 kilogram. So how many grams is in a kilogram? So let's go here. And if we have 1 gram, and we want to know how many kilograms that is, we're going to go back 3, right? 1, 2, 3. So 0.01. So 0.01 times 85 equals X times 10. Initial volume, final volume. 0.01 times 85, 0.85, 10x, x equals 0.085. And now that I'm looking at that, I'm not sure that that's the correct answer for that. So rather than stop and rework it and come back to you, let's work on this one together in class. If someone can figure out if this is actually right or if I made a mistake, I'll give you extra credit points for as many people that can figure it out. Let's go on to the next one. Okay. If 55 milliliters of an 18% solution is diluted to 330 milliliters, what's the new percentage strength? Oh, wait a minute. We haven't seen that one before. So 55 times 18 equals 330x. The x moved on us because we're looking for something different. And I'm going to go ahead and let you guys do the math with that. I'm going to do it up here. 55 times 18. I get 990 on this side. And 330x, which will make x 3. So the new percentage strength will be 3%. And the last one. If 2 fluid ounces, and again, I would make this milliliters. So 60 milliliters of a 25% solution equals X milliliters of a 5% solution. 60 times 25, I get 1500 equals 5x. X is 300. And that's in milliliters, right? So 300 milliliters divided by 30 milliliters per ounce equals 10 ounces. Okay? All right, the next chapter is allegations. It's my favorite one of the entire book, so I'll talk to you then. Bye.